In this video, I'm going to carry on with the conversation about the terms that are used in cybersecurity. Cybersecurity is based on ensuring three different principal properties of confidentiality, integrity, and availability, the so-called CIA triad. Confidentiality is the property of information security that information is not made available or disclosed to unauthorized individuals, entities, or processes. What information is deemed confidential is, of course, going to be subjective. That is, other than personally identifiable information which may be regulated by national laws and also social convention. And the confidentiality not only is subjective, but arises also out of an agreement between the parties involved. So, for example, it may be information relating to a company, like, for example, Apple, that staff are obliged not to disclose. And specific disclosures to staff and customers may be covered by a non-disclosure agreement. In the situation with Apple, staff are generally not able to discuss any new products that they're working on, and Apple takes that very seriously, including dismissing staff that have been found to take devices out of the company, for example, and showing it to other people. They were very keen on making sure that leaks about upcoming products wouldn't make it into the media. Of course, there are other types of confidentiality relating to national security, again covered by different laws. And finally, there may be information that a consumer wants protecting, e.g., for example, credit card transactions. Privacy is a part of confidentiality, but it's actually only a subset. Its definition is varied, but one of them is really concerns the right to keep information about yourself confidential. This includes what you do, when you do it, who you do it with, and where you do it. Australia has legislation which covers privacy, the Privacy Act 1988, and that operates on privacy principles. In other words, it's not a particularly strong set of laws and really works on the basis that people do the right thing about privacy data. The consequences for not doing this potentially are fines, but they're not in the same order of magnitude as you would see in the European Union, for example, with their regulations, or in some of the states in the US. Within Australia, we operate on a federation basis, and so not only is there national legislation, but there is, i.e. federal legislation, but there is state legislation as well, and WA has various parts of legislation that cover privacy, including the Freedom of Information Act, State Records Act, and Surveillance Devices Act. We'll cover those when we consider law and cybersecurity in about week 10. In terms of trying to keep things confidential, one of the important things is actually knowing what information you hold and potentially which information has to be kept absolutely confidential, or in this particular type of classification, perhaps top secret. So different organizations will have different ways of classifying data. In the military, there's the traditional way of unclassified, secret, and top secret, which is done on the basis of what the impact would be if that information was disclosed. And that impact is measured in terms of not necessarily just financial, but damage to the state itself. So in an organization, however, the information classification would really be on the terms of the sensitivity of it to the organization's interests. What we do to try and keep things confidential is to impose access controls, and that determines who or what gets to read, write, update, delete, and execute various bits of information. We can also implement another type of control to keep information confidential, and guard against accidental or malicious access to that data, and that's through encryption. And in the case of encryption, what we're mainly concerned about is encryption at rest and also in transit. Information management is an important part of this whole process and really concerns itself with the classification, the life cycle of information as it goes through an organization. One of the considerations is that not only once you've got information, how it's classified, and then what controls that you put on it, but also when it ends its life usefulness and has to be disposed of. And of course, there is a whole process behind getting rid of whether it's digital or actual physical information, so paper, for example, which should be shredded or given to a secure recycling facility. In the case of digital information that may reside on disks, there is again a process of wiping those disks and making sure that they're not available if that machine or the disk should fall into somebody else's hands. The whole process of governance, oversight of how the organization manages that data lifecycle, is also an important consideration. Integrity is the property of making sure that information you keep is actually consistent and it says what you think it should say and it hasn't been altered in any way. This is a classic XKCD cartoon which in somewhat dramatic fashion illustrates what happens when an application is not sanitizing its inputs. And so here we've got a student who's actually named Robert apostrophe open parentheses, close parentheses, semicolon, and then some SQL. SQL is a database command, and in this case, what the effect of this, putting it into the part of the application that takes the name would be the deletion of the students table within a database, obviously with some somewhat catastrophic effect. And so in this situation, the mother's being phoned by the school complaining about the fact that their database has been compromised because the son is actually named Robert, and the nickname for him is Bobby Tables. We're going to do some SQL injection which utilizes this technique in one of the labs, and so this becomes funnier once you actually understand what it means. So integrity protects the reliability and correctness of data, and we're concerned with preventing unauthorized alterations of data. And a good example of this is where you deposit $200 into your account and that balance is currently $1,000, and after the deposit you want to be absolutely certain that after the transaction it holds $1,200. Now there's an awful lot of things that can happen when you make a deposit, for example. It actually has to come from another source, and so in that the process of that transfer, you also don't want it to come out of an account and never reach the account it's going to be deposited into. Another one, then you get into a state of uncertainty where two accounts potentially have the wrong information in them. Another example is where you've submitted a legal contract and you want to know that it will not be altered after it's been submitted. And there is technology that we can apply to actually ensure that this doesn't happen, or at least we can check whether it has happened or not. We also want to protect against errors as well as deliberate changes. Of course, people can make mistakes on forms. That's a very common error that will lead to integrity issues. They may inadvertently tell somebody about something, or change one piece of data but not another, as in the case of the bank account, for example. And this may not be deliberate, it just may be an error. There are a lot of things that integrity sort of is related to and depends on, and in turn things that depend on integrity. So accuracy, truthfulness, authenticity, all of these features that are listed here rely and are related to integrity. Another issue which is outside of the CIA triad but often considered as important in information security is the concept of non-repudiation. This relates to the scenario where, in this case, John is claiming to have sent an email to change an appointment and is giving that as the reason why they didn't attend the appointment, and Joanna claiming that she never received the email and so was expecting John to be there. In that case, Joanna has repudiated John's claim, and what you really want to be able to do is to stop a subject from claiming that an event or action didn't occur. So this is an essential part of accountability. It relies on a proof of identity. So in this case, for example, where John actually sent an email, obviously Joanna didn't receive it, so it wasn't an issue. But let's have another example where not John, but some malicious actor called Eve sent an email saying that John wasn't going to be there when John was going to be there, and Joanna received it, and Eve was masquerading as John. In that case, you really want to be able to prove that it was John that sent it and not Eve. And usually we do this through a system of encryption or cryptography called digital signatures, and we'll deal with that when we cover cryptography. Availability is the third most important part of the CIA triad, and in this situation, availability rate relates to timely and uninterrupted access to objects, data and information they need, basically. So threats to availability include failure of devices. So if your phone fails, then you don't have access to it, for example. Or if you're trying to set up a Teams lecture and the Teams doesn't work, then availability is denied the students who are expecting to listen to that online lecture. Software errors can cause availability issues, but also environmental factors like fire, flood, wind, and power loss. Malicious examples of availability denial are things like distributed denial of service attacks, and this is where a malicious actor actually sends an overloads a system with requests, and there are multiple ways of doing this, and this denies access to that system to legitimate users because the system is just so busy dealing with all of these malevolent requests. A distributed denial of service is just a denial of service on a bigger scale where the attacks come from a range of different sources. Another case of availability, which also can compromise things like integrity and confidentiality, are ransomware attacks. So we can mitigate this, and we'll come into the whole area of mitigation when we dealing with attacks and risks in particular. But we can mitigate availability issues by having fault tolerance, backups, and fault tolerance, the case where a server goes down and you have something that's standing by that can be spun up and replace the server that's at fault. In the case of denial of service, of course, there are companies that will provide protections against those attacks, people like Cloudflare, for example, that will have not only fault tolerance, but geographically spread fault tolerance, so that if an attack is attacking an endpoint that's distributing content in Australia, they can switch to Singapore, for example. Disaster recovery sites, where there's been a catastrophic failure at a particular site, power's gone out, or in certain situations, I myself have experienced this, where a building is destroyed, then you can switch to a disaster recovery site. And of course, protections against those attacks in the first place. Turning to identity and authentication, we said that this was very important in terms of, and we'll see, accountability, but it's central to actually cybersecurity generally, especially for things like non-repudiation, but even for confidentiality. You can't actually be sure that you're sharing the right information with the right person if you don't know who they are, and that they have proved who they are. And that's the whole role of identity and authentication. And in this situation, what we have is a representation of the different factors that we can use to prove that a person is who they say they are. And in this case, Baidu at pirates.lilue.com. So the interesting thing about captchas is that they don't necessarily, the situation at the bottom there, don't necessarily prove an identity of a person, but they actually are supposed to prove that you're not a robot, that you are an actual human responding to a prompt. So identity, as I said, is about being able to prove to a system that you are who you say you are. And authentication verifies that identity using authentication factors. So this includes passwords, smart cards, other tokens, biometrics. And of course, you can combine these to have multiple factors. And we've seen more commonly this idea of two-factor authentication, where you have two different types of authentication that you can use. So sometimes factors are split into 4 or 5 different categories, or known as types. So there's type 1, which is something you know, which is a password, for example, or a passphrase. It also may actually relate to some piece of information that you know, like your date of birth, for example. Another type is something you have. That could be a smartphone, a smart card, some device that you have with you. Again, unlikely that an attacker, if they compromised your password, would necessarily have your smartphone as well, although it does happen. Type 3 is something you are or something you do. And in this situation, it's basically you are in a particular location, you're logging into a system as a doctor, for example, in an emergency department. And that also relates to somewhere you are, where you can geographically locate somebody and raise a concern if you're not in that location. So you may only allow logins from within a corporate network, for example. And there's also a combination of these factors where you use context-aware authentication, so you only allow people to log in to a system and authenticate during certain times, in a certain location, on a certain machine. For all this to work, however, the process of registration is critically important, proving your identity in the first place. For important things like passports, driving licenses, and other legal documents, we have a system in Australia where we have a point system, and you have to usually, for sensitive documents like passports, provide 100 points of identity, and that will include things like birth certificates, passports, driving licenses, that sort of information. And it's almost reliant on a chain of trust that when you present a passport, that you would have had to have gone through some proof of identity to get that. It's a bit like a student card or a staff card, where you would have to actually go to an office and prove who you are before you're given it. Now, of course, you can lose that, and that's why you might have a photograph on, which is another protective mechanism. It's still not foolproof, and this is why you combine these factors. Systems that are designed to manage this whole process of establishing identity and then implementing authentication, including the ability to do single sign-on, where you only have to log in once and then get access to a range of different applications, are called identity management systems. And there's a range of those and how they actually work. In the case of authorization, once you've established your identity and you've authenticated, so authentication is the process of establishing that you are who you say you are, then you are actually authorized to do something. And this is quite a complicated area and topic, but essentially authorization determines what actions a subject can carry out on an object. So this is what document you can access, and when you get that document, what you can actually do with it. On a computer system, it would be what programs you're able to run, whether you can read a particular file, or for example, and to implement that, we have access control schemes that come in a variety of different flavors. The most common one that we will deal with is discretionary access control, where a person is responsible for determining access to the files and objects that they own, and they can designate access to other people as well. On computer systems, usually access is reduced to read, write, and execute. Those are the three most important things, but you may also see access limited or controlled to create, read, update, insert, delete, and that's common on databases, for example. Accountability. This is an attribute where once you've identified people, you've given them authorization to do things, what you actually want to do is to be able to keep a record that actually worked, that the right people accessed information, or in fact, even if they were allowed to access the information, you may want a record to know that they took a specific action. This is really important, for example, if you're modifying a database. If somebody goes in and changes some details about you on a system, for example, in a student database or some other system, and that's wrong, or you didn't ask for it, then you won't be able to go back in and see who did what and when to that system and whether they were authorized to do that. So this is implemented using monitoring and logging, and at a very basic level, we essentially log every action that takes place on the system, but we can have very sophisticated types of monitoring that will look for anomalous behavior. And this is where things like AI and machine learning come in. Of course, we can also carry out audits, so it's not much point of logging things if nobody actually ever checks that everything was done according to your expectation.